Hi, this is Richard C. answering a question submitted by a student. This is a classic question for Algebra 1 or Algebra 2 students having to do with motion. And this equation is very famous. It was discovered by Sir Isaac Newton, and it's used all the time in the real world. And so it's nice to see this is still being taught, and I know I see it all the time in my tutoring. So you can see now you must be studying quadratic second degree equations and their graphs. You can see this is a second degree equation. Let's write it over here in a more recognizable way. S of t is really just the height at time t, and it's negative 16 t squared plus bt plus s being the initial height. And the initial height, he's jumping from ground level with it. So because he's jumping from ground level, the initial height is 0. So in this case, s of t is going to be negative 16 t squared plus vt. Okay, and I think a little graph helps also. So here's time, t, and here's height, which is s of t, and he's starting at ground level, and then he's going to jump in the air and come down again. You can see we have the flight of his path through the air is going to be a parabola. So what they're asking about is this point here. At what time does he land? Okay, so we're just going to figure that out, because when he lands, his height is going to be 0. Let's go ahead and solve this. So we're going to factor out a t. That's going to be negative 16t plus v. And we're told the initial velocity is 48, so let me put that in there. And all we have to do is solve this now. So this has two solutions. The t is going to give us t equals 0. We already know that at time 0, when he's starting, he's on the ground. This one is going to give us negative 16 t plus 48. T is equal to 0. That's not 48t, I'm sorry. That t doesn't belong there. Okay, so let's keep going. Yeah, see, the t has already been factored out. Okay, so negative 16t plus 48 equals 0. So 48 equals 16t. Divide by 16. 48 divided by 16 is 3. So at 3 seconds later, he will touch the ground. There are two things in a word problem that involve this formula that you always want to put the units here. Usually they're going to ask about the x-intercepts, which is where he started, and well, actually In this case, it's an x-intercept where he started. Sometimes they might start from an elevated platform or something like that, in which case it's not an x-intercept. But they are always interested in this x-intercept. They're almost always interested in this x-intercept because this is where the person or the object lands. And then also they tend to be interested in the vertex because this is how high this person is in the air when he's at his highest point. So that's often this, and they might want to know at what time he reaches the highest point, which would be here. And they would also want to know what the highest point is, which would be here. So they're either going to be interested in the vertex or in the x-intercept or in both. This one was just interested in the x-intercept. Okay, so I hope I demystified that to some extent and wish you luck in your algebra travels. See you next time. Bye-bye.